Hi everyone. So today we are going to say about means end analysis algorithm. It is nothing but it is a mixed search algorithm. In this we will first solve the major problem and then it comes down and then solve the minor problems. That is larger problems are solved at first and then the smaller problems will be solved later. So that is the major step that has been used in means end analysis algorithm. We can see with one simple example so that it is easy for you to understand. See, in the initial state, they had mentioned one square box. So inside that we have one circle, one diamond, and another one is one black dot. So this is the initial state. So what we have to do this, we have to in the goal state they have given one square box on one circle, one diamond. Outside the circle, we are having this diamond. In this, the diamond has been placed inside. So from this to we have to achieve the goal state. So what we have to do is here we are using some operators. So the operators are move, delete, and expand. So in this move is used to move the diamond outside the circle, and delete is used to delete the black hole, and then expand is used to expand and increase the size of the diamond. So these are the three operators that has been used to solve the problem. So first in the initial state, first we are using the delete operator in order to delete this black hole, and after that we are using move operator in order to move the diamond outside the circle, and in the third one we are expanding the operator, that is the expanding the diamond operator. So these are the three steps. So this is the initial state, and finally we have reached the goal state while using these three operations, that is nothing but delete operation, move operation, and then expand operation. So this is how means and analysis algorithm work. So the advantages of this is first it reduces the search space and systematic breakdown and flexibility, and the disadvantages are it is potential for tunnel vision and risk of local minima and requires metric precision. So these are the major disadvantages present in this problem. So and it is one of the most easier algorithms. So with the operators we can easily solve the problems. So the next one, we are moving for constraint satisfaction problem. In the name itself suggests that the problem have certain constraints and we have to satisfy those constraints in order to achieve the optimal solution for the problem. So so the components used are variables that has been given in the problems and domains. So according to the variable, the domain has been assigned and the constraints has been placed. With these three things, we have to solve the problem and we have to find the optimal solution. Let us see with one simple example. So here the example has been given 1, 2, 3, and 4. So the variables present here are 1, 2, 3, and 4. And the domains present here are red, green, and yellow. So these colors has been mentioned as the domains. See, the variable has been 4 and the domains has been 3. So we have to assign this particular domain to all these three variables and without any confusion. So without any confusion, for avoiding the confusions, they are giving certain constraints that 1 is not equal to 2 and 2 is not equal to, so and 1 is not equal to 3 and 1 is not equal to 4. So 1 is independent, that is not dependent on 2, 3, and 4. Our next constraint is 2 is not equal to 4 and 3 is also not equal to 4. So these are the constraints. With the help of these constraints, we have to assign the colors to the particular variable. So let us draw a table. In the table, I have assigned all these four variables. So in the initial domain, first let us assign 1 uh, to red. So all these three variables have all these three colors. So we have to assign one color to particular one variable. So first one has been assigned, let us assume this. First one has been assigned to red. So one has been assigned to red. So the remaining colors or domains are green and yellow, that may be assigned to 2, 3, and 4. So one is fixed, that has been red is fixed, that has been assigned to 1, and remaining colors are given to 2, 3, and 4. And in the next step we can assign green to variable 2. So in the next step, since 1 is assigned with red, we should not change this, and 2 was assigned with green, so the remaining color is yellow. So since 2 is equal to 3, so we can make green also to 3 and remaining color is yellow, and 4 we can assume yellow, But here the problem is that 3 is not equal to 4 and 2 is also not equal to 4. If 2 has been assigned with green, so 4 should not be assigned with green, so it has to be given some different color. And 3, if 3 has been assigned with yellow, 4 also should not be assigned with yellow. So here what is the only solution is we can assign 1 to red and green to 2, and 3 also we can assign the same green color because 2 is equal to 3. That constraint 2 is not equal to 3, that constraint is not given, so we can give the same 3 green to both 2 and 3, and finally yellow is separate color and that has been given to 4. So first we here we are making the backtracking problem, backtracing. So while using backtracing we can change this green and yellow option to green, and finally we have assigned yellow to 4. So this is the final solution, that 1 is red and 2 was green and 3 is also green because 2 can be equal to 3, and the remaining color is yellow that has been assigned to 4. See, the constraint has been satisfied. So 1 is not equal to 2, 3 and 4. So 1 is not equal to 2, 3 and 4 because red is given only for 1. And next one, 2 is not equal to 4. See, green and this is yellow, so this is not equal. So, these two are different colors. And the next is 3 is also not equal to 4. So these two also different colors, that is not equal. So the constraint has been satisfied and the solution has also been achieved. See, the solution is 1 to red and 2 to green and 3 to green and 4 to yellow. So this is the final solution we have obtained. And the advantages are it it provides a structured problem solving, and it has flexibility and modularity, and it reduces the search space. And the disadvantages here is it has scalability challenges and the complexity of constraints. So if the constraint is more heavy, we cannot find a best solution for the given problem. And it also provides incompleteness in complex scenarios. While the constraint becomes heavier, so in complex scenarios it doesn't provide any optimal solution. So that is the major disadvantages present here. So that's all about this algorithm, constraint satisfaction. So the next video we will see about local search strategies and adversarial search strategies. Thank you.